Right now, at this very moment, the universe is being ripped apart by a force so powerful and so mysterious that it makes up 68% of everything that exists. And we have absolutely no idea what it is. This invisible force is called dark energy. And it is not just sitting there passively. It is actively pushing every galaxy in the universe away from every other galaxy, faster and faster, every single second. By the end of this video, you will understand what dark energy is, how scientists discovered it completely by accident, and why it terrifies cosmologists when they think about the future of our universe. But here is the truly mind-bending part. Dark energy is not some tiny fraction of the universe hiding in the corners. It completely dominates everything. Matter, the stuff you and I are made of, makes up less than 5%. Dark matter, that other mysterious substance we have talked about before, makes up about 27%. But dark energy? A whopping 68% of the entire universe is this bizarre repulsive force. So what exactly is dark energy? Well, that is the trillion-dollar question. And the honest answer is we do not really know. But we can tell you what it does, and trust me, it is absolutely wild. Let me take you back to 1998. Two teams of astronomers were studying distant supernovae, expecting to measure how much the universe's expansion was slowing down due to gravity. See, for decades, everyone assumed that after the Big Bang, the universe had been expanding, sure, but that gravity from all the matter in the universe would be gradually slowing that expansion down. The big debate was whether there was enough matter to eventually stop the expansion completely and cause a big crunch, or if the universe would just keep expanding forever, but slower and slower. But when these astronomers looked at their data from distant type 1a supernovae, they saw something that made absolutely no sense. The universe was not slowing down at all. It was speeding up. The expansion of the universe was accelerating. This was like throwing a ball into the air and watching it go faster and faster instead of falling back down. The discovery was so shocking that both teams checked and rechecked their calculations for months. They thought they had made a mistake, but the data was solid. In 2011, Saul Perlmutter, Brian Schmidt, and Adam Rees won the Nobel Prize in Physics for this discovery. They had found evidence for dark energy, even though nobody knew what it was. Now, dark energy is not a thing in the traditional sense. It is more like a property of space itself. Imagine space as a fabric that can stretch. As the universe expands, you would expect that fabric to get thinner, more diluted. But dark energy does not work that way. As space expands, more dark energy appears to fill it. It has constant density, so the more space there is, the more dark energy there is, which creates more expansion, which creates more space, which creates more dark energy. You see the problem here. What makes dark energy truly bizarre is that it has negative pressure. Now, negative pressure sounds like science fiction nonsense, but it is a real thing in physics. Normal matter and energy have positive pressure. And here is where it gets really weird. In Einstein's equations of general relativity, negative pressure creates a kind of anti-gravity effect. Instead of pulling things together, it pushes them apart. Dark energy is basically the opposite of gravity on cosmic scales. While gravity tries to pull the universe together into a big crunch, dark energy is winning the tug of war. As of 2026, the expansion rate of the universe is about 70 kilometers per second per megaparsec. That is the Hubble constant. What that means is for every 3.3 million light years of distance, space is expanding at 70 kilometers per second. The farther away something is, the faster it is moving away from us. Eventually, galaxies will be moving away from us faster than the speed of light. Not because they are moving through space that fast, but because space itself is expanding between us and them. In fact, there are already galaxies so far away that their light will never reach us, no matter how long we wait, because the space between us is expanding faster than light can cross it. So how do we actually know dark energy exists if we cannot see it or touch it? Well, scientists use several independent lines of evidence. First, those supernova observations I mentioned. Type 1a supernovae are what we call standard candles. They always explode with the same brightness, so we can use them to measure cosmic distances precisely. When we look at distant supernovae, They are dimmer and more redshifted than they should be if the universe were slowing down. This tells us the universe is accelerating. Second, we have the cosmic microwave background radiation. This is the afterglow of the Big Bang, and it has tiny temperature fluctuations that tell us about the geometry and composition of the universe. The pattern of those fluctuations matches perfectly with a universe that is 68% dark energy, 27% dark matter, and 5% normal matter. Third, we can look at how galaxies cluster together over cosmic history. Dark energy affects how structure forms in the universe. Computer simulations that include dark energy match what we observe. And fourth, we have baryon acoustic oscillations. These are ripples in the distribution of galaxies left over from sound waves in the early universe. They give us another way to measure cosmic expansion. All four of these completely independent methods point to the same conclusion. Dark energy is real, and it is dominating the expansion of the universe. Now, even though we know dark energy exists, we have no idea what it actually is. There are several competing theories, and none of them are particularly satisfying. The leading candidate is called the cosmological constant. This is Einstein's old idea that empty space itself has energy. He originally introduced it for the wrong reasons, but it might actually be correct. If dark energy is the cosmological constant, it means vacuum energy is a fundamental property of space-time. Empty space is not really empty. It is seething with quantum fluctuations that create this repulsive force. But there's a massive problem. When physicists try to calculate how much vacuum energy there should be based on quantum mechanics, they get an answer that is 10 to the power of 120 times too large. That is not a typo. The theoretical prediction is off by a factor of 1 followed by 120 zeros. This is called the cosmological constant problem, and it is one of the biggest embarrassments in theoretical physics. Another possibility is that dark energy is not constant at all. Maybe it is a dynamic field called quintessence that changes over time. This would mean dark energy could get stronger or weaker as the universe ages. Or maybe Einstein's general relativity is wrong on cosmic scales, and we need a modified theory of gravity. Some physicists think dark energy might not be a thing at all, just a sign that our equations break down. Whatever dark energy is, it is going to determine the ultimate fate of the universe. And let me tell you, the possibilities range from lonely to absolutely horrifying. If dark energy remains constant, we are heading toward what is called the big freeze or heat death. The universe will keep expanding forever, getting colder and more dilute until no stars can form. Eventually, in trillions and trillions of years, even black holes will evaporate through Hawking radiation. The universe will be a cold, dark, empty expanse with nothing but isolated particles drifting through an incomprehensibly vast space. But if dark energy is increasing in strength, we could face the big rip. In this scenario, dark energy would eventually become so powerful that it would tear apart galaxies, then solar systems, then planets, then atoms themselves. Some calculations suggest the big rip could happen in as little as 22 billion years from now. That sounds like a long time, but cosmically speaking, it is actually terrifyingly soon. If you found this video mind-blowing, smash that like button and subscribe to Your Space Wizard. We make the universe accessible and we post new videos every single week. Dark energy is the ultimate cosmic mystery. It dominates the universe, controls its fate, and we barely understand the first thing about it. But that is what makes science exciting. Right now, as you watch this video, space is stretching. Dark energy is pushing the fabric of reality apart. And somewhere out there, astronomers are working day and night to figure out why. The universe is far stranger and more mysterious than most people realize. And dark energy might be the biggest clue we have that we're missing something fundamental about how reality works.